All right, so on the back, all I did was I took my data from the front that we got green twice and we get orange 8 times. So if we want to know the experimental probability based on the results of our experiment, green, number of times the outcome happened, would be 2 out of number of times the experiment was performed, 10. So we got green 2 out of 10 times, which is 1/5. We got orange 8 out of 10 times, which is 4/5. So that's our experimental probability based on the results of the experiment. What was the probability that we pulled out? Now this says popsicle stick. Obviously I had to use toothpicks, but what was the probability that we got a popsicle stick? Well, every single time the only thing we could pull out was a stick. So we would say the probability of a popsicle stick, or in this case a toothpick, was 10 out of 10, or 1. We were certain to pull out a stick. Certain is the word that you use when it is a guarantee, when it is the only possible outcome. What was the probability that we pulled a hippopotamus? Well, last time I checked, there were none in there, so we pulled out hippopotamus 0 times out of 10, which is 0, and we would say that it was impossible. Now, the one thing you wanted to be careful of is that you don't mix up an experimental probability of 0 with a theoretical probability of 0. Experimentally, we pulled hippopotamus 0 times. Theoretically, it is also 0 out of 10. They both happen to be 0 out of 10. Now, I could have performed this experiment and gotten green 0 out of 10 times, but I wouldn't have put that it was impossible because we happened to not pull out greens. It just didn't happen. Hippopotamus, however, is impossible. If I had pulled out orange all 10 times, notice I wouldn't have written certain for orange. It wasn't certain that I would pull out orange, but I might happen to pull it out 10 out of 10 times. In this case, the first draw and the second draw are independent. And the reason for that is that I put the stick back. Well, the first time there were 10 sticks, there were 5 orange, 5 green. Well, when I pulled a stick out and went, yep, I got orange, and then I put it back in, the next draw, I had exactly the same possibilities because all 5 orange and all 5 green were back in the jar. So because I put the stick back, they were independent. If we did not replace the sticks each time, the outcome would be dependent. And that's because my first stick would then impact the probability of the second stick being chosen. Whether you're using experimental results or theoretical information, you can predict what you think might happen if an experiment was performed a certain amount of times. The easiest way to do this is with a proportion and proportional thinking. Suppose you're going to spin the spinner right 30 times. How many times do you predict you should land on a baseball hat? So first we'd want to know, what's the theoretical probability? If I'm the person working for the Fisher Cats and I've got this prize wheel and I need to sort of say, hey, how many baseball hats do I need to bring to the game because I might have kids winning them? Well, theoretically, 1 out of 6 sectors has baseball hat. So I'm predicting that 1 out of every 6 kids might win a baseball hat. So equal proportionally, how many kids do I think are going to win a baseball hat out of 30 spins? So proportional thinking, we can do our cross products where we say, 6 times x has to equal 1 times 30. Divide both sides by 6. X equals 5. We're predicting how many times we think the baseball hat will actually land, how many times the spinner will actually land on baseball hat out of 30 spins. We think we're going to have to bring with us 5 hats because we think out of 30 spins, 1/6 of the time it will land on a baseball hat. We need to make sure we have 5 hats with us. Now that's not a guarantee. It could be more times, it could be fewer times, but that's a reasonable prediction. And that's how we use proportions. So what about out of 600 spins? Okay, well if it was 1 out of 6, how many out of 600? So you can think about it like a proportion. This is one you can probably do in your head though. If it's 1 out of 6, how many out of 600? We can reasonably assume that's going to be 100, right? 1 out of 6, 100 out of 600. Now 50 spins, we're probably not doing that one in our head. So 1 out of 6 equals x over 50, and we would solve the proportion and say it's going to land on baseball about 8 times. And then 1,000 spins. So if it's 1 out of 6, how many out of 1,000 spins? And that's around 167. Notice both of these, I put the approximately symbol because they actually came out to be not a whole number answer, so I rounded them. Joe pulled a ping pong ball out of a bag, recorded the results, and replaced the ball 100 times. He drew a green ping pong ball 25 times. How many times do you predict he would draw a green ping pong ball if he were to perform the experiment 500 times? So first, what happened when he did the experiment? Well, he did the experiment 100 times. So whatever it is, it's going to be out of 100 times that he performed the experiment. Out of those 100 times, he drew a green ping pong ball, 25 of them. So 25 times out of 100, he got green. So let's look at this proportion. If 25 times out of 100 he got green, proportionally, how many X out of 500 do we think he'll get green? So we would do 100 times X equals 25 times 500. I do actually need to do that. On the previous one, it was a 1. So that's 12,500. Divide both sides by 100, and you would get X equals 125. So if 25 times out of 100 he got green, we predict that 125 greens will be drawn out of the next 500, right? 125 green out of 500 total draws. So how many times do you predict that's going to happen out of the next 600, out of the next 90, or out of the next 5,000? Each time you're going to do the same thing. What happened when he actually performed the experiment? 25 out of 100. How many out of the next 600? 25 out of 100. How many out of the next 90? 25 out of 100. How many out of the next 5,000? And you'll solve each of these proportions the same way. Cross products, divide both sides. You could also, especially because it would keep your numbers lower, you also could have set this up as 1/4 because 25 over 100 is the same as 1/4. And you could have done 1/4 equals X out of the new total number of draws. And so each one of these you're going to, 4 times X, 1 times 5,000, divide both sides by the number next to the X. And in this case, I'm getting 22.5. Now, doesn't make a lot of sense. You're not going to get 22.5. Oh, I'm sorry. That's the wrong, not 22.5. That's really small. 1,250. So you would get 1,250 out of 5,000. This is actually the one. 4 times X equals 90. This is the one when you divide both sides by 4, you get 22.5. So up here, we can't say 22.5 times we're going to get green. We could say approximately 22 or 23. And this first one was 150. So we can use an experiment that we perform to predict what we think is going to happen if we were to then perform the experiment more times in the future. Thanks, guys.